On June 9th, 2026, a powerful storm system brought exceptionally heavy rainfall to southern Indiana, creating one of the most intense precipitation events the region had experienced in recent years. Meteorologists had been monitoring atmospheric conditions for several days, recognizing that a combination of abundant moisture, atmospheric instability, and a nearly stationary frontal boundary could support prolonged thunderstorms, capable of producing extreme rainfall. The weather pattern began developing during the first week of June as warm, moisture-rich air from the Gulf of Mexico spread northward into the Ohio Valley. At the same time, a weak frontal boundary extended across the Midwest. Because the front moved very slowly, it provided a favorable environment for repeated thunderstorm development. Forecasters noted that the atmosphere contained unusually high levels of humidity, creating conditions that favored efficient rainfall production. During the evening of June 8th and continuing through the early hours of June 9th, clusters of thunderstorms began organizing over southern Indiana. Rather than moving steadily across the region, many of the storms repeatedly formed over the same areas. Meteorologists refer to this process as training, a phenomenon in which successive storm cells travel along nearly identical paths. Training thunderstorms are capable of producing extremely high rainfall totals because precipitation continues to fall over the same locations for extended periods. Atmospheric measurements showed that moisture levels were well above normal for early June. Strong southerly winds continuously transported warm and humid air northward from the Gulf of Mexico. This moisture provided thunderstorms with a constant source of fuel. As air rose into the upper atmosphere, water vapor condensed into droplets and released heat, strengthening the storms and allowing them to persist throughout the night. The thunderstorms that developed on June 9th were characterized by towering cumulonimbus clouds, reaching heights of more than 40,000 feet. Powerful updrafts carried moisture high into the atmosphere, where cooler temperatures promoted cloud growth and intensified rainfall. Frequent lightning illuminated the skies as electrical charges accumulated within the storm clouds. Residents across southern Indiana reported continuous thunder and repeated flashes of lightning accompanying the heavy rain. Meteorologists observed that the atmosphere was highly unstable. Warm surface temperatures combined with abundant humidity allowed air to rise rapidly once lifted.
Our front porch.
Cooler air at higher altitudes increased the difference in temperature between atmospheric layers, further enhancing thunderstorm development. These conditions supported vigorous convection and helped maintain the strength of the storms for many hours. One of the most remarkable aspects of the event was the slow movement of the weather system. In many situations, thunderstorms move quickly enough to limit rainfall accumulation. During this event, however, weak steering winds and the presence of a nearly stationary front caused storms to either move slowly or repeatedly redevelop over the same locations.
Take a picture. Hey, we're going to save these people. I done saved one.
One just jumped out. One just...
This significantly increased rainfall intensity and prolonged the duration of the event. Weather radar imagery revealed wave after wave of thunderstorms developing along the frontal boundary. New storm cells continuously formed as warm, humid air flowed into the region. Satellite observations showed expansive cloud tops and strong convective activity extending across portions of Indiana and neighboring states. Meteorologists described the storm structure as similar to organized mesoscale convective systems that are capable of producing widespread heavy rainfall. Rainfall rates during the strongest storms exceeded 2 inches per hour in some locations. Such rates are considered extreme and can occur when atmospheric moisture is exceptionally abundant. Because the atmosphere was nearly saturated, much of the moisture condensed and fell directly as precipitation, making the storms highly efficient producers of heavy rain. This efficiency contributed to extraordinary rainfall totals in a relatively short period. Electrical activity remained intense throughout the night. Powerful updrafts within the storm clouds caused collisions between ice crystals and water droplets, creating strong electrical charges. This process produced frequent lightning and prolonged periods of thunder. Observers reported that lightning flashes occurred repeatedly, creating dramatic nighttime conditions across southern Indiana. Forecasters from the National Weather Service had recognized the potential for excessive rainfall in advance. Watches were issued as atmospheric conditions became increasingly favorable, and warnings were updated as thunderstorms intensified. Meteorologists emphasized that the primary concern was the extraordinary amount of rainfall associated with the slow-moving storms, rather than damaging winds or tornadoes. By the morning of June 9, 2026, meteorologists recognized that the combination of tropical moisture, strong instability, and a stationary boundary had produced an unusually intense weather event.
Comes the dumpster. It's deep enough.
The storm demonstrated how persistent thunderstorm development and abundant atmospheric moisture can transform a typical early summer pattern into a significant rainfall-producing system. It also highlighted the complex interaction between moisture transport, atmospheric instability, and storm organization that can lead to exceptionally heavy precipitation across the Midwest.
Get in that van with that there because it's holding the water back off of it.
Yeah.
Thanks for watching Severe Weather, where we break down the facts behind nature's most intense moments. If you found this video helpful, please like, comment, and subscribe. Your support keeps this channel going. Hit the bell so you never miss a real, calm, and clear report. See you in the next one. Stay informed, stay safe.